Welcome back everyone to the quadratic formula. We are now going to take a look at examples with non-perfect squares. And the big thing I need to tell you with non-perfect squares, no decimals. You just learned in the previous lesson how to simplify square roots. And so that's what I'm going to be expecting you to do, is to simplify square roots. All right. So 3x squared minus 8x plus 1. Our a is 3, our b is negative 8, and our c is 1. So we're now going to plug it into the quadratic formula. Now, when your b is negative and we're plugging it into a negative, it becomes positive. So we have 8 plus or minus the square root of negative 8 squared minus 4 times 3 times 1 all over, 2 times 3. That 2 looks wonky, so I'm going to fix it. 2. Same process. We're going to simplify inside the square roots. Now, make sure you keep the parentheses when you're multiplying this out. Parentheses need to be around this negative 8 before you square it. Otherwise, it will not come out correctly. And we simplify the bottom. So we get 8 plus or minus the square root of 52 all over 6. We now need to simplify the square root. So, if not a perfect square, simplify the square root. So 52 is not a perfect square. So we're going to do what we did in the last lesson. We're going to break 52 down into our prime factor tree, and we get 2 and 26. We get 2 and 13. 2 is prime, and 13 is prime. So we get 2 times 2 times 13. Find the pair. Keep 1, chuck 1. So 2 comes to the outside, and 13 stays inside. So we're going to replace radical 52 with 2 root 13. So we have 8 plus or minus 2 root 13 all over 6. We are not done yet. Look at all the numbers outside the square root. 8, 2, 6. Ask yourself, can I simplify those all together? And yes, we can divide a 2 out of those 3 numbers. So that is what we're going to do. We get x is equal to 4 plus or minus radical 13 all over 3. And this is our stopping point. So you don't need to split it apart. You don't need to do decimals. You just need to simplify those 3 numbers if you're able to, just like how you would simplify a fraction. Let's practice another one. 3x squared plus 14x plus 3 is equal to 0. So my a is 3, my b is 14, my c is 3. So we have negative 14 plus or minus the square root of 14 squared minus 4 times 3 times 3 all over 2 times 3. We're going to simplify under the square root and the denominator, and we end up with negative 14 plus or minus the square root of 160 all over 6. So now we need to check the square root of 160. It is not a perfect square, so we are going to break down 160. So we get 2 and 80, 2 and 40, 5 and 8, 2 and 4, 2 and 2. So we're going to circle all our primes. And then we're going to simplify. 1, 2, 3, 4, 5. 1, 2, 3. Yep, 5 2s. And a stray 5. We have one pair of 2s and a second pair of 2s. Keep 1, chuck 1, keep 1, chuck 1. So left inside is going to be root 10, and coming out front, 2 times 2 is 4. So we have negative 14 plus or minus 4 root 10 all over 6. Once again, we need to check to see if the numbers on the outside can be simplified. Yes, they can. We can divide a 2 out of those numbers. So we get x is equal to negative 7 plus or minus 2 root 10 all over 3. All right. One last one and we'll be good to go for the quadratic formula. As you can see, it's not equal to 0, so I'm going to add 27 to both sides. So we have x squared minus 9x plus 27 is equal to 0. So our a is 1, our b is negative 9, and our c is 27. So we have 9 plus or minus the square root of negative 9 squared minus 4 times 1 times 27 all over 2 times 1. I'm going to simplify the bottom and underneath the square root. So 9 plus or minus the square root of negative 27 all over 2. All right, now we need to simplify the square root. So as you can see, we have a negative on the inside. So we're going to bring out that negative, and there's going to be an I in front. We now also have to break down the 27. So 27 gets broken down to 3 and 9, and 9 gets broken down to 3 and 3. So we have the square root of 3 times 3 times 3. We have a pair of 3's. Keep 1, chuck 1. So we have 3 root 3. But don't forget that I that we brought out in front. So we have 9 plus or minus 3i root 3 all over 2. We check to see if any of our numbers on the outside can be simplified. 9, 3, and 2. Those cannot get simplified any further. So x is equal to 9 plus or minus 3i root 3 all over 2. And there you have it, our dip into the quadratic formula.